Okay, 2D. This is like the penguin question about when the min-max question for the penguin question. This one's a min-max question for shoppers. We're told the rate which the shoppers enter the store is S. The rate which they're leaving the store is L. Now, as long as S is bigger than L, the amount coming in is bigger than the amount coming out. Oh, crap. Sorry. S was actually the number of people who entered the store. Oh, crap. Hold on. Keep in mind, there's something a little bit weird going on here. S is the number who actually entered the store. This is just the number enters, not the rate. Here, leaving, this one was in a rate. Okay, so what that means is S plus the integral of L is the number of people, no, minus the integral of L, right? This is a little bit weird, okay? This is not the same as the penguin question. Sorry about that. They give you S, okay, which is the number of people that have entered the store at any moment in time. This is the rate which they're leaving, so you have to integrate that to get that. Now that makes this for weird. What you're gonna have to do, how am I gonna figure out when that's the max or a min? I need to figure out the derivative equals 0, right? So I need to figure out when S prime equals L. Well, actually, technically, it's S minus. The key to this question is that it's S prime equals L. So this is a little bit different than the penguin question, actually, from the first one. Because in the penguin question, they were both rates. So this one's a little more confusing. This is the actual number of people who went to the store. This is the rate which they're leaving the store. So you have to integrate the rate to get the number of people who left the store. So there's people that entered the store, there's people that left the store, so then you can subtract it and figure out how many people are in the store at that moment. But to figure out the max or min, I need the derivative. So again, but in this sense, it's like the penguin question. S prime is the rate which they're entering the store. L is the rate which they're leaving the store. What you're gonna have to do is put this in the calculator. So you're gonna have to actually take that derivative and put that in your calculator, and then you're gonna have to put the L function in the calculator in Y2, and you find an intersection. Now it turns out it intersects at, the time that it intersects at is 5.45066. Let's see. Yeah, you might not be able to read it. Hopefully you can. So now, when is something at a max or a min? At its endpoints, 0 and 12, or at this number here, 5.45066. Now, you're gonna have to, you're gonna have to put 0 in for S, and then you're gonna have to do the integral from 0 to 0, which is gonna be 0, which is good. There were 0 people at the beginning. Then you have to put that number into S, and then you have to go 0 to that number here. Whatever number here is 0. I'm gonna put 0 in, and I'm gonna put that number in, and then I'm gonna put that number in. Maybe I should make it a box. 0, I'm gonna put the 5, 4. And then in here, you're just gonna actually, put the 0 and you get a number. So you're gonna have to do some calculations here. And then this turns out to be 36.2. Around that to a whole person. I know it didn't on its answer key, but just kind of find it morbid that they have part of a person there. 196. I round these to whole numbers of people. Oh wow, I don't know if a store can hold. Number of shoppers in the store at its greatest was 1,000. There's a lot of people in the store. It must be a big store. So anyways, this is the most number of people in the store. Is that the question? At which these. Oh, it actually wants the time. At that moment in time, that's when the most number of people will be in the store. Okay?